Good day everyone, this is the report of Group Jollibee. Instruction processing and data path single cycle. What is single data path? Single data path is equivalent to the original single cycle data path. The data memory has the only one address input. The actual memory operation can be determined from the memread and memwrite control signals. There are separate memories for instructions and data. This is the example of single data path cycle. Why does single cycle data path require separate instructions and data memories? The data path must have separate instruction and data memories because the formats of data and instructions are different in MIPS and hence different memories are used. This is the example of single data path requires separate. How does a single cycle processor work? A single cycle CPU example. A single cycle CPU executes each instruction in one cycle. In other words, one cycle is needed to execute any instruction. In other words, our CPI is 1. Each cycle requires some constant amount of time. Single cycle processor use one clock period per instruction and the clock period is set by the total delay of the slowest instruction. This is accomplished by adding state registers between the instruction of fetch, instruction decode, execute, memory access, and write back stages of the circuit. Single cycle data path.
Single cycle data path. Single cycle implement the assume each instruction is executed in one clock cycle, which each component memory, ALU, etc. can be used only once. Reason for assuming separate instruction and data memories. Advantages of this single cycle data path is simpler to design. Disadvantages: the speed of the machine is determined by time for the longest path. Memory access is much slow than register access, but most constructions use only registers. Better, each instruction type can be different of clock, different number of clock cycles. Common elements for all instruction fetch, PC update, access 1 or 2 registers. Instruction fetch used by all the instruction memory. Input instruction address and output instruction. How to build differ until later. Program counter register the containing address or current instruction. Other ALU with only one operation. Combination circuit. Input to operand, output sum.
Sa loading store. Sige lang. Sa pang Japan na
Instruction fetch. PC gives address to the instruction memory and memory outputs instruction component. Increment PC. PC value is a first operand, input and other. Contains 4 is used. Seconds operand input to other. PC plus 4 is a stored pack in PC. Repeat once each clock cycle. Register access or R type. Components. Register file 32 registers input. two read register number 5 bits each, one write register number 5 bits, write the data 32 bits, output read the output to read data values 32 bits each, control read write determines whether to write data target or register 1 bit. LUA performs arithmetic logical operations, input two data values 32 bits each, output result of operation 32 bits, 0 result is equal to 0 1 bit, control A- ALU controls select operations 3 bits, single cycle data path is implementing R-type memories access that branch jumps instruction single cycle path. Each instruction takes one clock.
Load and store. Load and store instructions are LW $RT offset open parenthesis $RS close parenthesis. SW $RT offset open parenthesis $RS close parenthesis. Requirements: add 16-bit offset value to contents of base register $RS. Extend 16-bit value to 32 bits for addition. For loading instructions, write value from memory into register $RT. For store instruction, read data value from register $RT. Components: data memory inputs, address, open parenthesis, 32 bits, close parenthesis. Write data, 32 bits, output, read data, 32 bits, control, mem read, mem write, sign extend, input, 16-bit data, output, 32-bit data with sign bit repeated 16 times. Branch. Branch on equal BEQ $RS $RT offset. Requirements: compare contents of two registers. Shift 16-bit offset left by 2 bits to get word address. Add, add shifted offset value to value of PC plus 4 to get branch target address. Update PC with branch target if operands are equal. Branch is taken. Two operations, compare and add, also modify instructions, fetch data path to allow PC to be updated with new value. Jump requires different address calculation, replace lower 28 bits of PC with 26 bits from extraction, shifted left 2 bits to be added later. That's all, thank you.